Okay, honors geometry. Here's an honors section only. 5.3 and 5.4 combined, talking about points of concurrency in triangles. Our goal today is to create what's called the Euler line for a triangle. And we'll talk about that as we get to the end. In addition, two of these ideas, the circumcenter and incenter, will help us make the circumscribed circle and the inscribed circle of a triangle later when we talk about circles. So keep that in mind as you go through today. All right, so here we go. So what is this point of concurrency and this idea of concurrent? Well, when you have three or more lines intersect at one point, they are concurrent. So two lines, of course, just intersect, nothing special. But when you have three meet at exactly the same point, we get this new idea called concurrent, right? And again, that point at which they intersect is called the point of concurrency. Now, the idea here is that, say you have this point, right? And we have 1, 2, 3 lines that intersect at that point. Let's make that point a different color, right? Well, if I want to find that point, do I really need all 3 lines? Like, if I take this third line and get rid of it, don't 1 and 2 still intersect at that point? Yes, they do. So despite these pictures involving three of the objects, because it's a triangle, 3 sides, 3 angles, you only need to do 2 at a time. So when we do these constructions through Desmos geometry, you'll see that I only do 2 of the 3. Okay, so the first one talks about the perpendicular bisectors of a triangle. So for the perpendicular bisectors, if you were to construct all 3 perpendicular bisectors for the sides of a triangle, they would meet at one point, and that point is called the circumcenter. So up here, point P is called the circumcenter. Now, the big thing about the circumcenter is that it's the same distance from the corners of the triangle. So P to A is the same as, never mind. Just P to A is the same as P to B is the same as P to C. Okay? Equidistant from the vertices. All right, so let's go ahead and draw this in Desmos geometry. So to do that, let's get out of here. Let's go. Let's just make a generic triangle. I'm going to try to make it acute, but not isosceles or equilateral. Let's label this ABC just for kicks. Okay, we're going to cheat when it comes to the perpendicular bisectors. We're going to make the midpoints of 2 of our sides using the more tools midpoint. Let's do AB and let's do BC. There's my midpoints. And now we're going to construct perpendiculars going through those midpoints. So let's construct perpendiculars to this line through that point, to this line through that point. And notice that this point right here where they crisscross, this is my circumcenter. And I'll go ahead and label that as the circumcenter. Okay, now, and again, the circumcenter is equidistant from A, B, and C. So now, what about the type of triangle and where the circumcenter is located? So this triangle is acute, right? All 3 angles are acute. Notice it's inside the triangle. I'm going to move C so that angle B becomes a right angle, and watch what happens. As I become more like a right angle, look at where that circumcenter goes. It goes along the side of the triangle. This is actually the hypotenuse, right? So if you have a right triangle, your circumcenter is the midpoint. It's actually the midpoint of the hypotenuse because it has to be equidistant from A and C. And then if you keep bringing C out so that B becomes obtuse, now notice where your circumcenter is. It's outside the triangle. Again, still equidistant from your 3 vertices. Okay, so that's the circumcenter. Okay, let's go back to our notes and we'll do the next one too, which involves the angle bisectors. So this is actually 5.3 because it involves both bisectors. So now what about where the angle bisectors? So the bisectors of the angles of a triangle are also concurrent. That point of concurrency is called the incenter, and it's equidistant from the sides of the triangle. So here's P, so they created these extra points, X, Y, and Z, so that P is equidistant from those sides of the triangle. So now when we do this construction in Desmos geometry, we actually have to do it because there's no good way aside from measuring and just, trying to eye it up. There's no good way to do this. So I'm going to show you how. Okay. So I'm here in Desmos geometry. Let's go back to that generic equilateral triangle, A, B, and C. And over here, I'm going to draw this generic circle. And I'm going to label its radius, because this is how you use a compass in this software. You need a circle to choose from. So if I go more tools, compass. So choose a radius, and now I can copy this circle. I'm going to copy it on angle A. When you do that, remember, you need to create these 2 points, right? And now I can hide this circle. So hide. And now from these 2 points, I'm going to use this compass again. Click compass, click on this segment, put the center on that point, do compass one more time, click on this segment, and put it on this bottom point. And now I want that point where they intersect right there. And now I can hide these 2 circles. And what I've just done with this ray is I've connected A to this point, and there is your first angle bisector. Angle A is being bisected. Notice as I move C around, that angle bisector moves with A. Let's do the same thing with B, okay? So let's compass. Let's take this radius. Let's bring the circle up here. Let's put points right there and there. How about I hide the ones on A first? Let's hide that point so we're not confused. Hide that point. And now we can hide the circle. And now grab the compass again. Pick the radius. Put it on this point. Grab the compass again. Pick the radius and put it on this point. And again, where those 2 circles meet right here, that is that second point I need. We can hide the circles. We can hide these side points. And we can draw this ray. And there is the second angle bisector. And again, let me move C so that, okay, so there. So notice that where these 2 points meet right here, or these 2 lines meet, that point is the incenter. Now, because I constructed this way, sometimes the line disappears. So if it goes away, don't be mad. It's okay. But let's talk about the different types of triangles. So when it is acute, notice it's in the middle. Okay, it's in the triangle. Notice that as the angle becomes a right angle, it still stays inside the triangle. And as it becomes obtuse, it still stays inside the triangle. And the idea is that it has to be the same distance away from the 3 sides, right? From the 3 sides. So it can't be outside the triangle because it obviously would be closer to this side than those 2 sides. So that's why it stays in the middle. And that's called the incenter. Yeah. So I'm going to make a second video talking about the other 2 points of concurrency.